So, in the last session, you all have asked me about the questions in the test. So when I checked, yeah, there is some problem in the questions. So what we will do is like today I will complete the topic which we are started yesterday, and then I will give you one another test by tomorrow, just for a practice. Okay, it is not for the like it is not going to be count for the marking and all, and we'll discuss some questions there. All right.
Yes, ma'am.
Hmm. Means I will give you questions, uh, or maybe a Google form if possible, and then you can solve this in the after the session. Maybe I will provide a Word document or a Google form. Uh, Depends. It's just for the practice, nothing else. Okay, so now yesterday we were discussing about the mega, right? I have given the input file. I hope you all have downloaded that input file which I have shared in the drive. And today we are going to start about that. So is my screen is visible?
Yes, ma'am.
Uh, just a second. Okay. So here you have to open the mega. I have already discussed all the options basically which is required. Then now whenever we are constructing the phylogenetic tree, that first of all we need to do the alignment, right? So here we are having the alignment option. We are going with the align. And here it's like edit and build alignment. Open the saved alignment session, show the web browser, query databanks, and do the blast search. So there's many options we are having. So if you wanted to build a new alignment, you are going with the edit and build alignment. If you want to give with the sequence files, edit the sequence files which have already there. Or if you want to open a saved alignment, maybe if you have performed already the alignment, you saved it and you want to open that, you can go with this option. You want to show the web browser, then query data banks, and then you want to do the blast search. So that also you can do. Okay. Now, as we want to build a new alignment, we are going with the first option, edit and build alignment. Then here we are having a three option, create a new alignment, open the saved session. So if you want to create a new alignment, then open the saved session, which is already saved there, and retrieve the sequence from file. So as we have a file where we are having a sequences, and from that we want to build alignment. So the third options which is selected, that we are going to check and then say okay here. So it's going to be like here you need to be select the input file, that's mega input file.
Ma'am, can you tell that again? How you opened the sequence?
Yes. So what you have to do is you have to go with the align, edit and build alignment, then retrieve sequence file you have to open as it is. Yes, sorry, you have to keep as it is because we are retrieving the sequences from file. Say okay. So it is navigating to the file explorer. You have to select the folder where you are having the input FASTA file. You have to select the input FASTA file and say open. That's it. Okay.
Yes, ma'am.
Hmm. So right now we just open the sequences. Yeah, yeah, please open it and tell me when it's done. So total 10 sequences are there.
Done, ma'am.
Okay. Now, once you open this, we want to perform the alignment. Here we are having the option for the alignment. But first of all, you need to select the sequences, select the basis or the sequence. Because right now only the M, like a first amino acid is selected. We want to do it for all. So you have to do the control A so that all the sequences are selected. And then you have to go with the alignment. So now for the alignment, you can see that like there are two options we are having, like align by the cluster W or align by the muscle. So cluster omega or the muscle. You can select the tool by your choice by which you want to perform the alignment. So as we have performing the cluster W or cluster omega, here we can select it. Okay. Then next, if you will see that it is showing it is performing a two types of alignment, like a pairwise alignment and the multiple sequence alignment. And in the pairwise and the multiple sequence alignment, it is showing the two options like a gap opening penalty and gap extension penalty. So do you have any idea what is the opening penalty and the extension penalty? What is the gap opening penalty and the extension penalty, and how to decide these values?
No.
Hmm.
No
Okay.
idea, ma'am.
Okay. So basically, whenever we are running the alignment, so selection of this gap opening penalty and the extension penalty, it's very important option for obtaining the accurate sequence alignment. And in Mega, whenever we are using the cluster W for the multiple sequence alignment, so basically these parameters control how the gaps are introduced and extended within the alignment, because whenever we are having a like multiple sequence, so if we are comparing, there are some chances like in sequence we are having a gap. So how we are introducing those gaps and extended those gaps within the alignment, so this we are going to decide by these two options, opening penalty and the extension penalty. Now, let's understand this gap opening penalty and the extension. So, opening means what? Actually, this is a cost of introducing a new gap in alignment. I will repeat it. This is the cost of introducing a new gap in the alignment. So, higher the gap opening penalty makes it less likely for gaps to be introduced or leading to the fewer but longer gaps. Means what? If you are keeping the higher gap penalty, so it makes less likely for the gaps to be introduced, so it is giving a less gaps for the like less gaps introducing there. And extension penalty means what? So this is a cost of extending a existing gap by one position. So let us consider at the third position, if you have one gap, so it is going to be extend the gap by one position, like 4, then again 5. So likewise it is going to be extend the gap positions by 1. So lower the gap extension penalty makes it easier to extend the gap. So we want the higher opening penalty and the lower extension penalty. So what are the default values now? So actually this mega, it is providing us the gap penalties that are generally suitable for wide range of alignment. The default are based on the empirical data and the common use cases. So in the cluster omega, default value for the opening penalty is a 15 and the extension penalty is a 6. Okay, what is the default value? 15 for the opening, 6 for the extension. So let's take one example. Suppose you have some set of protein sequences with moderate divergence. Okay. So what default run you are giving? Like you are giving the gap opening penalty 15 and the extension 6. So perform the alignment and evaluate. Now, if you want to adjust for the moderate divergence, so you can give the lower gap penalty as 10 and the extension penalty as 3 and perform the alignment and compare the result. And maybe if still your alignment is not optimal, if it's not accurate, you are not feeling like it's a proper, so you can give the intermediate values like 12 for the opening, 4 for the extension. Are you getting my point? Hello?
I think it will be clear when we actually see it because we
So at
can
that
do.
Ma'am,
time, then what? Okay, I will explain it maybe with the help of whiteboard, so you it will be more clear. Okay. First of all, I will just write the definition so that so the first we are having is a gap opening and another we are having is a gap extension. So what is the opening penalty means what? It is cost of introducing a new gap. So cost of introducing the new gap. And then extension means what? It is going to be extend the gap by one position. Okay. So this is the main thing. Now, what is the default value of opening penalty? It's 15. And what is the extension penalty? It should be 6. Okay. Because higher the value of gap opening penalty make less likely to be introduce the gap and lower the extension penalty it makes easier to extend the gap, so that's why we are keeping highest as the opening, lesser as the extension. So 15 and 6 is the default value. But right now, how to decide like which gap opening and extension penalty is better, how it is giving us the alignments, what value we have to give. So if you are confused in between that, so let us consider you have some set of proteins and right now you're not aware, like you don't have any idea how to give the value. What you can do in that case is first you give the opening 15 and then 6 as the extension. Then just perform the alignment and see the result. You can evaluate how you are getting the alignment. Then maybe if you want for the moderate divergence, like if you are not getting a proper results or the results which you are expecting, so for the moderate divergence then you can run. So here you can give 10 as the opening and 3 as a extension penalty. Then what you can do is you can perform the alignment and then you can compare the results. If you're not sure what to give, so you can perform by both the way by giving both the values and then you can compare. And still, if you're not getting the optimal results, if the alignment is not optimal, so you can give the intermediate values, then give the opening as 12 and extension as 4. Clear? So this is how basically you can give the values. You can perform the alignment using a 3 different values and then you can compare the results. Okay. I'm just telling you for now, right now we are running it only for one value because our aim not to generate not to give this values, our aim here to construct the tree. But this is just I'm telling as a like information. So in future, if you are dealing with these values, so you should know how to give it, right? Is it fine now?
So these
Yes, ma'am.
values depend on the sequence, the type of sequence,
No, these are the default values for all protein or nucleotide.
but then we are changing them, right? To see,
It's just
to
to
create
compare
their.
how we are getting.
Okay.
Yeah, it's just for the comparison, ma'am.
Okay.
Okay?
Yes.
Yeah. Is it clear to everyone?
Yes, ma'am. Got it.
Okay, fine. So now what I'm doing is I'm keeping the default values. Okay? 15, 6. Let's see how we are getting the result. Then you want a negative matrix. No, we don't want negative matrix. Then delay of diversion cutoff. If you want the diversion cutoff delay, so we don't want. We are keeping these values as it is, and then just say OK. And here you can see we are getting the alignment result. Can you try? Tell me up to here when it's done.
Ma'am, can you tell the values once again?
15 and 6.
In
This
pairwise or in multiple?
both I changed.
Okay.
Yeah. Done? So what we have to do is I'm asking to everyone if you need some time, please tell me. I will wait. Okay. Now you have to export this alignment because right now we have performed the alignment. So we are going with the data. And here, if you want to create a new file, open the alignment, save the session, export the alignment. So yeah, we want to export the alignment because we want to construct the phylogenetic tree in which format you want. You want a mega format, FASTA format, or a Nexus format. Okay. So I want it in the mega format because mega file required basically to generate or to construct the tree. But if you want your alignment file, just want to for the alignment, you can retrieve it into the FASTA format also. So I'm just creating the mega format and then you have to save it. So you can give the title mega and say, okay, this is the input title. So you can see inside the folder, we are having the file with MEG extension, mega file. Can you just do this?
Done, ma'am.
Okay. What about others?
Done.
Done, ma'am.
Okay.
Yes, ma'am.
So once we have completed the alignment, now we are going to construct the phylogenetic tree. So to construct the phylogenetic tree, we are going with the option phylogeny. Okay. So in the phylogeny now, if you will see that we are having a total 5 algorithm by which we can construct the phylogenetic tree. So that is the maximum likelihood, then neighbor joining, a minimum of evolution, UPGMA, then maximum parsimony. Now, which algorithm we have to use and what is the meaning of that algorithm, that I will tell you shortly. Okay. So first algorithm we are having is a maximum likelihood, which is denoted as ML also. So actually, what it is doing, it is going to evaluate the different possible trees and chooses that one maximize the likelihood for observing the given sequence data under a specific model of evolution. Means it is going to evaluate the different possible trees and chooses that one maximizes the likelihood observations. So basically, this algorithm is produces the highly accurate trees with the complex models of evaluation, but actually it's a computationally intensive and it's a complex algorithm. So if you want, now I will explain first of all their use means like their description, strength and the weakness, and then I will tell you which you can use at what time. Okay. Then next algorithm we are having is a neighbor joining. So basically this neighbor joining algorithm, it's a distance based method it is, which is constructing a tree by iteratively finding the pairs of operational taxonomic unit. Operational taxonomic unit as in what? You can say it's a representative sequence. So this representative sequence, it is minimizing the total branch length at each step. So here, actually, this neighbor joining algorithm is a fast and efficient, which is suitable for large data sets. So if you have large data sets, you can go with it, but it is less accurate and it's for the complex data. Accuracy is less here. Then next algorithm we are having is a minimum evolution. So basically this minimum evolution algorithm, it is finding the tree with the shortest branch length, total branch length. So it is minimizing the overall evolutionary distance then. But here it is finding the tree with the shortest branch length, but here it is less accurate, sensitive to errors in the distance estimation. Means like if there is a distance, so at that time it is sensitive for the error and accuracy is less. Another we are having is a UPGMA. UPGMA, that stands for unweighted pair group method with arithmetic mean. Unweighted pair group method with arithmetic mean. So basically this is performing a hierarchical clustering. So this hierarchical clustering that assumes a constant rate of evolution and builds the tree by clustering the pair of taxa based on the average distance. Means it is a building a tree by clustering the pair of taxas, but it is based on the average distance. So it is a simple, fast method, assumes a constant rate of evolution. but it produces a less accurate tree if the assumption of constant evolution is violated. So if you're not able to give that value correctly, it will not produce the accurate tree. And the last one you're having is a maximum parsimony. So basically this maximum parsimony, it is identify the tree topology that requires the fewest evolution changes, or you can say the mutation, to explain the observed sequence data. So it is seeks for the tree with the fewest evolutionary changes, but it can be misleading when the evolutionary rate is widely among the all branches. Now, out of these five algorithms, which one is better? So basically, if you are looking for the accuracy, at that time, maximum likelihood is generally considered is the best choice for computational resources. If you are looking for the speed and efficiency, neighbor joining is the best method for the large data sets when the computational resources are limited, although you have to sacrifice for some accuracy then. And if you are going for the specific data set threads, so consider the assumption and limitations for each method. For instance, then UPGMA, that is assuming a constant evolutionary rate, which may not hold the true in all cases. So uh, this is what like this is how you can decide which algorithm you have to use. But means in conclusion, if I will tell you, the best method depend on balancing the need of accuracy, computational feasibility, and the specific characteristics of your data sets. So researcher actually it is employing the multiple methods and then compare their results to ensure the robustness and the reliability. So still if you can't decide, so that's the best way. Perform with every algorithm and then compare. Okay. So as I want the accuracy now, I'm going with the first one. But is it clear what I want to tell?
Ma'am, can you repeat for the third one? Uh, Minimum evolution.
Minimum evolution. Yeah, sure. So basically, minimum evolution, it is finding the tree with the shortest total branch length. Okay, and it is minimizing the overall evolutionary distance. Means it is finding the aim of the algorithm is what, to find the tree with the shortest total branch length, but it is giving you the less accurate tree and it is sensitive to the errors. Okay.
Yes, ma'am, got it.
Yeah, what about others?
Yes, ma'am, it is clear.
Okay, now I'm selecting the first one. Then you have to select the file. You have to go inside the mega folder and mega input and open it. Then here, basically you are selecting the statistical method, that is maximum likelihood. Then in your case, actually it is having like none here. But here I'm selecting the bootstrap method. What is a bootstrap method? Basically, bootstrap method is what? Actually, it's a statistical technique which is used to estimate the reliability of the phylogenetic tree. Means basically it is involving the resampling data from the original data set. What is the purpose of this bootstrap method? So the main goal of the bootstrap method is to access the confidence level, you can say, or to support the various branches in the phylogenetic tree. And it helps to determine how strongly the observed grouping of taxa, like a species or a sequences, is supported by the data. So basically, this bootstrap, you can say, it's giving you the confidence. Okay. So actually, the thing is, minimum value you have to give here. The minimum bootstrap replication, it should be 100. Okay. Minimum bootstrap replication here you have to give, it should be 100. But maximum you can give by your choice, but minimum you have to give 100, so that 100 times it is going to be repeat. 100 times it is going to be give check that tree, and then it is giving you the result. It is going to generate the tree. So that's the thing actually, like we have to focus on. So what we have to do is like right now we don't have that much time because it will take a very long time for the 100. So I'm giving it 50 for now, but it is just for the demo which we are checking over here. When you are dealing with the real time data, minimum you have to give the 100. Okay, then rest of the things will be like heuristic method and all. You have to like it's already set for the maximum likelihood method, so you don't need to be changed it because it's as it is you have to keep. Then last it is showing number of threads, like at how many number of threads you want to run. Number of threads means what? Like a number of processors. How many processors for how many processor you want to run your data phylogenetic tree. So how to check like how many processors you are having, because in my system it is different, in your as per your configuration it can be different. So you have to go with the system information, and here in the system information you are getting the processor. So how many processors you are having here? You can see total 4 cores I am having, means 4 processors I am having. So out of that I am giving 2. So let us consider if you have a 4 processors, you cannot run on 4 out of 4. You have to run it either on 3 or 2, because if you are running on 4 cores, it is going to be harm your system. It is going to stuck the system basically. So if you have 8, you can run on 6 or 4. If you have 4, I'm running it on 2. So this is what you have to select the option. Can you just try? Can you just select?
Yes, ma'am.
Okay.
Ma'am, can you show how to check that again? Number of processors.
Huh. You have to go with the system information. Okay. And then here you have a processors, like a 4 cores. These are your number of processors.
Ma'am, if we have more than 4, then like we can select a higher number.
Yes. But it should be 4 cores, because there is a logical processor also. We are not dealing with the logical processors. 4 cores. If you have 8 cores, then yes, you can select more numbers.
Ma'am, mine is 2 cores.
Run it on one only.
Okay, ma'am.
Yeah. Yeah.
Then, ma'am.
Done. So now what you have to do, you just have to say okay, and here it is running. See, it's like showing one is done, 1 out of 50 is done, 2 out of 50 is done. So till it is showing you the 50 replications, we have to wait. But I'm repeating this again, and this is very important. In real time, minimum you have to give 100. Okay?
No, and we don't change the substitution models or anything.
No, no. These are the values actually when we have selected the uh, maximum likelihood. So no need to change.
Okay.
Ma'am, done, ma'am.
Okay. Like all for all 50 it's done?
Yes, ma'am.
Yeah, ma'am.
Okay. Yeah, just wait. Let the result generated here so that I can explain. Hmm. Okay, so here if you will see that like the tree is generated, okay, then this is what the original tree and this is what the bootstrap consensus tree. So bootstrap values which I have told you like a number of confidence or the number of iterations. Then next we are having over here is this 2.4, 3.3. This is what? This is a branch length. Okay. Branch length means what? Actually, it is a measure of the evolutionary distance. Means basically it is expressing in the terms of number of substitution per sites. Means the nucleotide or the amino acid change that have occurred along the branch. Okay, then how we are measuring it? So basically the unit of measurement, it's a substitution per site. So this unit actually it's reflecting the average number of changes, that is mutations that have accumulated per site, which is position in the sequence along the branch. So for the nucleotide sequence, the branch length are often measured in the number of nucleotide substitution per site, means like zero point 0.1 substitution per site. And for the protein sequences, so branch length are similar to the measure in the number of amino acid substitution per site. So this is what it's a substitution per site. Okay. So how to interpret it? Basically, longer the branch length, it is indicating the greater evolutionary divergence and it is suggesting more accumulated changes over the time. And shorter the branch length, it is indicating the less evolutionary changes, which is suggesting the closer or like closer evolutionary relationship with the taxa. Right? But here we are having the original tree, and this is what a bootstrap tree. So this bootstrap tree, these values are giving you the confidence. We'll see that. But now here, if you will see, first of all, the option, if you want to export the session, if you want to save the current session, what I will do, I will save this current session because we need this tomorrow. If some options are left, I will explain that tomorrow. So that is what first and foremost thing, you can save it. Then export the current tree in the NAVIC format. Actually, what is this NAVIC format? It's required for annotation. Means let us consider you are giving some names to this taxonomic node. So here for this we are having some IDs. So right now you're not aware maybe what organism it is. So for this, if you know any name, like this ID is for which name, which organism, this is for which organism. So if you have such kind of annotation and if you want to edit that tree, basically you require this NAVIC format there. Then export the analysis summary, partition list if you want to export, the group names or import it or import some name translation. So this is what option we are having. Then for the searching, if you want to search a particular taxa, so you can search here. Then if you want to save this as a PDF, PNG, SVG, this image, then there is an option of subtree. I will explain that subtree and all options. So this is just like for the change, means if you want to change it, you want a traditional tree, rectangular, or a straight tree, or if you want a curved tree, you can just select your choice from here, right? Then if you want a circular tree, you can also select that circular tree. So this is, the choice is completely yours how you want your tree. That is what the different options it is giving, like a swap the sub tree, compress it. So that's what the thing here. Then if you want to view view the options, like if you want to hide the overlapping taxas, if you want to arrange your taxa, like which is as per the balanced shape or as per your input order you want to arrange, then how you want your tree style, traditional, circular, which I have shown. Then if you want to hide or show something, if you want to hide your taxa names or a marker or your nodes, so you can just show them or hide them. Then font, if you want a taxon name font, branch information font, or ancestral state font. So this is also you can select. Then for the compute, if you want to compute the condensed tree, then here we are having the options for ancestors. So basically here also on the downside also we are having the option. I will explain that. But basically this is how we can generate the tree. Now, here on the left side, this is what option you can see for hiding the taxon name. When I clicked it, it is hiding the taxon name. Then for the layout, basically, here if you will see about the layout, so you can change the different layout and you can increase the tree width also. You can increase the tree height also here. So this is how you can edit it, right? Then here we are having the option of subtree, subtree. So this subtree actually it's a in this section or a branch of phylogenetic tree. It is extracted by a selecting node, or you can say which is a common ancestor and all the descendants. So it forms the self-contained evolutionary lineage. So here in the subtree option, you are having the different option like how you want your tree. You want a pointer tool, you want a display subtree separately, if you want a rotate tree, swap tree, or a flip the tree. So this what editing option you can do. Then if you want to display the branch length, you can just, no, this option is not visible here, not an issue. Next option you are having, that is a frequency info. So in the frequency info means what? Or it's a statistics info. It means actually it's a bootstrap support values. So basically these bootstrap support values that are a percentage, which is indicating the proportion of the bootstrap replicates. Means here if you have a 10%, if you have a 20-30%, if you have this kind of value, so at that time you can understand that. Just a second, I will show you. Hmm. So in the statistical info, you can see the frequency, or if you want to just if you want to give just the numbering to the node IDs as per the uh, confidence or the replication, then here you can increase the font size of that statistics info. Then here placements you can give the automatic or for the above as per the above branch, as per the below branch. Then distance from node in pixel, you can just increase the pixels. You can see how distance you want, horizontal from the node and vertical distance. You can arrange how you want, right? Then higher values, lower than. So if you want to hide the values lower than like for the specific length, you can just give that number also. So generally, we are getting this frequency info in the form of these numbers. And if you are getting in a form of percentage, let us consider for the original tree, if I will show you. So here you can see when I selected the site coverage, you are getting this frequency value or frequency info in a percentage format. So what it is indicating, it is indicating the percentage of the bootstrap replicate. 10 means what? The branch or clade, it was supported in a 10% of the bootstrap replicate. 20 means 20%. So this is what it is giving you the replicate percentage. So you can just increase, decrease the horizontal length, vertical length from the branch. You can increase and decrease the font size if you want. Then placement, you can give the automatic above the branch length, below the branch length. So you can just give like this how where you want the placement. So this is what the frequency info you are having related with the uh, statistics or the frequency. Is it clear? This is the editing option of your tree, which is I'm showing to you. Hello, am I
Yeah,
audible?
ma'am. Yes, ma'am.
Yeah,
Yes.
this is clear. The statistics.
Yes, ma'am.
Then here the branch length is also like the same thing. This is what the branch length. You can see point per substitution per side, sorry. Then here placement also the same thing where you want to give precision, like you can give the uh, how many numbers you want after the pointer or after the decimal point. So that precision you can just give. If you increase, you are getting that precision values there. Okay. Then next we are having that is a distance scale. So what is the distance scale? Basically, it's a distance scale which is representing the quantitative measure of genetic or evolutionary divergence between the sequences or a taxa. So it is often expressed in the unit of reflect amount of changes or mutations which is accumulated over the time. So here also like you can keep the distance scale line with you want with a 3 point or a 4 point. Then font size also you can just select which kind of font size you want, regular or like a color, which kind of color you want. Maybe I'm giving a maroon color here. You can select. So this is what the distance scale. Okay.
There was no difference, right, when this line width will change in
Yeah.
the distance.
Yes. Obviously. Actually, there is a slight change we are having. So basically, this distance scale, if I will tell you more about it, it's a means it's what actually it's measuring the evolutionary divergence or a genetic distance between the sequences or a taxa. So if the distance scale of 1.01 of the molecular phylogenetics, it is indicating the moderate level of the genetic changes. Actually, right now in this tree we are not having, but in some cases in some tree there is a one line we are having at the downside, like a horizontal line we are having at the downside. So that is what the distance
Ma'am,
scale
it
we
is
are seeing.
showing in mine.
Is it so? It is showing in yours.
Yeah, it is a like I've been wondering, but like mine looks a little bit different from what yours has come out, and to me
Okay.
it is showing that distance scale line.
Can you just share your screen
Yes, ma'am.
so everybody can see?
Ma'am, can you also check if I did something wrong because I like it appears a little different from what yours has come out. So
How many bootstrap value replicates you given,
50 only,
and the penalties?
15 and 6.
Okay. Can yeah, please share the screen. We'll check. But what about others? Is it showing the same tree, which is uh, so you guys are getting the exactly same tree how it is looking in my system?
Yes, ma'am.
Ma'am,
Okay.
we are not getting that length.
Branch length, right?
Branch
Branch,
length.
sorry,
Yeah, ma'am.
distance scale, sorry.
Yeah, ma'am.
Sir, Pushpit,
Ma'am,
sir,
is it
it's not
visible?
visible. No, no, no. Means I can't see, but what about others? Is it visible?
No, ma'am, it's not.
Okay. Like this is a very small horizontal line. Can you just increase the line width? See, it's like that. Can you decrease it, make it one? Scale length. Can you increase the scale length from 0.10 to? Yes, see, slightly it is increasing. Can you see everyone?
Yes.
Yeah, it's slightly increased. This is what we call it as a distance scale actually. So now I will explain you what is this distance scale. Actually, in the context of phylogenetic tree and the evolutionary analysis, so this distance scale, it's referring the measurement of evolutionary divergence, like how evolutionary divergence are there and the genetic, or you can say the genetic distance between the sequences, taxa or a species. So if the distance scale is like 1.01, right now it's 0.3, but if the just I'm telling the example, if your distance scale is 1.01 in the molecular phylogenetics, so it is indicating the moderate level of the genetic divergence. So with the average 0.01 substitution per site between the sequences. So it provides the quantitative insights into the evolutionary relationship, which is helping us to construct the phylogenetic tree that is accurately reflect the genetic distance or the evolutionary history. So right now, if we are having a very less value, 0.30 or something, so because I have taken this sequences from a one species only. Like these are the sequences from the Saccharomyces species only. That's why you're not getting that much difference, that much divergence. But if you are taking with the distantly related sequence, the value will increase. Okay, that's what the distance scale actually, which is showing you the evolutionary divergence or the genetic distance. Is it clear? Because our sequences are closely related, it is not having that much difference, so that's why the values are less. But if you have a very distantly related sequences, so obviously at that time it will be changed. Okay, it will increase. And one more thing, right now, whenever you are dealing with the proteins, okay, I will tell you that tomorrow only, because for the nucleotide, you will get one option during the phylogenetic reconstruction that I need to tell to you. So please save this session. I will explain rest of the option by tomorrow, and for the nucleotide sequence also. Maybe if I have some practice example, I think I have. Yeah, I have for the nucleotide. That will try for tomorrow. Okay.
Ma'am, how do we save it?
You just have to save the session. Just a second. Is my screen is visible?
Yes, ma'am.
Hmm. So, actually, what you can do is, okay, I think I have closed it. No, no, no. Yeah, sorry. So, what you can do is you can just go with the file and then save the current session. Okay. So, then when you closed it, save session, same with this. And now when I closed it, so here in the folder, one mega file is created, MTX file. So when you will open here, the previous session is going to be open. Okay. So we'll discuss that then by tomorrow.
Okay, ma'am. Thank you.
Okay. All right then. That's it for today. Tomorrow, actually, we are just like we will see this also, and I want to install the Linux in your system, right? Means like there is a one session left for the Pymol, which is going to be conducted by the another trainer who is expert in CAD. So she will conduct your session on Friday, but tomorrow, as we are like required one session for the Mega, and I will just set all the requirement for the Linux installation also. Because what we have to do, like once we select the options, the required option, we need to restart the system. So that's why tomorrow only we are going to do that. So please available tomorrow, because without that option, then we are not able to install the Linux. Okay.
Okay, ma'am.
Mm. Okay. All right then. Bye. Have a great day.
Thank you, ma'am.